Today I'm going to use a 130mm amateur telescope to photograph a black hole that is 2.4 billion light-years away. Its mass is about 1 billion times that of the Sun. I don't know if we can capture its jet. It is 3C273. By the way, which object would you like to see next? Let me know in the comments. Hi everyone, I'm Ethan. This is a very unusual target. From the very beginning, its discovery was legendary. Many people think it was discovered by an optical telescope. It wasn't. It was first discovered by radio telescopes. 3C stands for Third Cambridge Catalogue of Radio Sources. 273 is simply its catalog number. In the late 1950s, radio astronomy was just getting started. Astronomers quickly discovered a large number of extremely bright radio sources. The problem was, radio telescopes at the time could only provide a very rough position. Inside that area, there could be thousands of stars or galaxies. Without precise coordinates, astronomers had no way to truly look at what it actually was. But soon, 3C273 broke the deadlock. It lies close to the ecliptic, in the direction of Virgo, with a declination of only +2 degrees, almost on the celestial equator. This position was crucial, because it meant the moon could occult it. On August 5th, 1962, and October 26th, astronomers at the Parkes Radio Observatory in Australia, led by Cyril Hazard, used lunar occultation to observe 3C273. When the moon passed in front of it, the radio signal suddenly disappeared. When the moon moved away, the signal returned. By precisely timing these changes, they were able to determine its position with arc-second accuracy. To make this possible, the team made major preparations. To aim the dish lower in the sky, they removed ladders from the antenna structure, polished metal parts, and even dug a trench so the dish could point to a lower angle. They even temporarily closed nearby roads to avoid radio interference from vehicles. All of this just to capture a few seconds of signal change. By the end of 1962, after multiple observations and calculations, the precise coordinates of 3C273 were finally locked in. And it is because of those coordinates that I can point my amateur telescope at it today. Now compare that to our 13cm APO telescope. In 1963, astronomers used the Hale telescope at Palomar Observatory to study this object. Its aperture was 200 inches. It cost $6 million at the time. When they looked at its spectrum, everyone went silent. The spectral lines made no sense. It looked like something never seen before. Until astronomer Martin Schmidt realized those lines were not strange new elements. They were hydrogen lines shifted by an enormous redshift. The redshift was the approximately 0.158. At the time, such a large redshift was unheard of. A redshift of 0.158 means it is receding from us at about 43,500 kilometers per second, around 14.5% of the speed of light. It also means this object is extremely distant, about 2.4 billion light-years away. But here's the real question. An object that far away should be incredibly faint. Yet 3C273 is still very bright. Even in visible light, it is not faint. Its apparent magnitude is about 12.9, which many small telescopes can detect. Its absolute magnitude is about -26. That brightness is astonishing. Here's an example to help you understand. If 3C273 were reduced to the brightness of our Sun, then the Sun's brightness would be like a firefly seen from 400 meters away. Its total power output is about 2 trillion times that of the Sun. Recent studies also show that this powerful object changes brightness over time like a flickering flame. This tells us it is not only bright, but also very compact in size. On such a scale, it is so bright. So what exactly is this thing? In high-resolution optical images, besides the extremely bright core, we can see a tiny host galaxy structure and a jet. The jet extends for tens of thousands of light years. It is formed when particles near the black hole's accretion disk are accelerated by strong magnetic fields and launched at nearly the speed of light along the black hole's rotation axis. At first glance, it looks like an ordinary star, but its distance, mass, scale, and luminosity are nothing like a normal star. These objects are called quasars. More precisely, it is a type of active galactic nucleus. In other words, it is a supermassive black hole at the center of a highly active galaxy. Our goal in this project was to try to capture that jet. With a 130mm telescope, that is not easy. We drove 60 kilometers to a small island in the middle of Taihu Lake, Bortle, Class 5 skies. The first attempt ended in failure. The challenge was not exposure time, but finding it. Even with accurate coordinates, we selected the wrong preset target and ended up pointing in the wrong direction. After stacking all the images, 3C273 was nowhere to be found. Only thousands of stars, and some galaxies hundreds of millions of light years away. Later we realized we were off by 103 degrees, completely the wrong direction. Fortunately, winter brings clearer skies. During the Chinese New Year, we had a second chance. We also chose a level 5 light pollution area in the center of Taihu Lake, where the fog was quite heavy that day. When the first 5-minute exposure appeared, I saw a familiar triangle of stars. Among those 3 stars, the one at the top was not a star. That was 3C273, a quasar 2.4 billion light-years away. After stacking 3 hours of exposure, the image became brighter and clearer. Next to the bright core, a very faint thin line appeared, so faint it was almost indistinguishable from noise, but its position matched historical observations. That thin line may be the jet. If it is real, it means we captured a relativistic jet 2.4 billion light-years away. 2.4 billion years ago, complex life had not yet appeared on Earth. That light began its journey. It traveled through an expanding universe. And today, it landed on a CMOS sensor. It appeared on a computer screen. From the 64-meter radio dish in Australia, to the 200-inch Hale telescope, to a 130mm amateur refractor. The universe hasn't actually changed. It's just that we can now participate in it with an amateur device. The next target may be even farther, even harder. What celestial bodies would you like to see filmed by us? Leave a comment below, and your favorite might just appear in the next video. If you want to witness it, please subscribe us. See you next time. Goodbye.